Hello TVers, welcome to SCALE Conference Chemtech 2026 Mumbai. So today I am with a very interesting guest. Can you give us our introduction?
Yeah, my name is Devavrat Menon and I'm founder's office at Uravu Labs. So we are a Bangalore-based company. We're making water from air. And we're also a cooling tower replacement. For the past couple of years, we've been running a 5,000 liter per day unit, which is a first of a kind plant in Bangalore. And with the water that we're getting from it, we've been catering to Horeca in Bangalore. Several major clients of ours include like BYG bars, RBI, and several of the five-star hotels. And last year we had our first machine sale and deployment in Abu Dhabi, where we sold a 200 liter per day machine, which is being used for hydroponic farming. And we're slowly starting to scale up and looking for industrial pilots.
Okay, so how does this core technology works that you are able to consume heat and give water out of it? So how does this magic happens?
Yeah, so it happens in like two stages. We have an absorber and a desorber, where in the absorber we have a liquid desiccant which keeps absorbing moisture from the air and which gets passed on to the desorber. So in an industrial setting where there is waste heat, we take in the waste heat which is taken up at the desorber side with a heat exchanger, and the liquid desiccant releases the moisture in form of vapor, and you get water as a byproduct of the cooling, the heat sink that we are offering.
So it's a open system, right? You have to have open air with humidity. What sort of relative humidity that you need in order for this system to work?
We can go as low as 20% RH, which not a lot of other atmospheric water generators can go to. And the best thing about it is that our OPEX still stays pretty consistent with any other atmospheric water generator, especially ones that are condensation tech. As soon as the RH drops, the cost of your water skyrockets. That does not happen with us.
Okay. So does it have to be a very, what you call very clean sort of environment, or it can handle dirty air or something like that?
Yeah, it definitely can handle dirty air and everything, because one, we have filters right next to our fan. So when we are blowing in air, everything gets filtered. Secondly, our liquid desiccant has affinity only for water molecules. So it's not going to, pick up pollutants and any other particles that are there in the air.
So the water that you are absorbing and desorbing, it's a relatively just water vapor. There is no contamination. There is no acid rain or something like that.
Yeah.
Okay.
So it's almost zero TDS. So you're getting distilled water, and so it depends on your application. So if you're looking for something like pharma grade water type ASTM type 1, type 2, or you're looking for distilled water for battery applications in, let's say, automotive, any of these applications you're completely open to. And also if you're looking for drinking, beverage, F&B kind of applications, you just have to simply formulate the water to bring it up to 60 TDS, which is the recommended drinking. And you can do that, in a very manual way, or we can integrate that for you in a dosing system. So the water that's coming out directly from the machine is good for you to use.
Okay. So what sort of physical size we are talking about? Like how big are these units? Like let's just say give an example of what you have installed. How physically big it was? Because again, surface area is also a consumable item. So as in because again, if you do not have a space for it, so what sort of size we are looking at?
So our 2,000 liter per day unit is the size of a standard shipping container. So about 20 feet.
So are you talking about you feed in air into this, or do you have to have different air catcher or something like that?
No, everything is into this. So it's a simple shipping container size device, and it's very plug and play. So right now we are developing also a 30,000 liter per day and a 10,000 liter per day. So that will be about 60 meters squared kind of situation, but a little bit taller. So
okay, so as long as we can ship it, most likely you companies and industrial partners should have enough space to deploy this. And you are doing double duty. Basically, you are a very good heat sink. You are sinking heat, and you are also basically removing humidity from air.
Yes.
And that humidity reduction is also distilled water, which you are getting without contamination.
Yes.
So that water is actually useful for, well, everything basically. It's useful for everything. Now the most important part at this point is how much parasitic energy consumption you have, like for fans, pumps and all that. Turns out if that becomes too huge, it might defeat the purpose. So what sort of power consumption we are looking at?
So we're looking at about 10 to 15%.
Okay, so power consumption is large. Okay, now we are talking about heat. What degrees of Celsius you need heat wise? What you're looking for?
So ideally, we're looking at low-grade waste heat. So that's somewhere between 30 to 60, early 70s kind of waste heat.
Okay, when you're talking about this sort of degrees Celsius, does it have to be higher than the ambient air?
Yeah, it definitely has to be higher than the ambient air, but it's also still low grade. So, there are a lot of applications where you can have that, even in industries where there is actually high grade waste heat. Through various processes, you still end up with some low grade waste heat that you can always still, tap into.
Okay, so what would you say that you would require in terms of T delta? Basically, let's just say ambient.
Yeah.
And how hotter the hot source should be that you can work at optimum efficiency. What would you say that?
So that would be about 20 degrees. 20 degrees would be.
So let's just say if my ambient is hot India 50 degrees Celsius, as long as your 70 degrees Celsius heat, you can I got this, you can easily work on that. Okay, so what about patching the system in tandem with some other devices like air conditioning unit? So you can do dehumidification for them and also act as a heat sink for them. So have you tried in something like this?
No, but we are in the process of beginning our pilots on this front, and the main benefit of this would come out in terms of OPEX savings for cooling. So we're definitely reducing the load that the device would have in terms of both dehumidification and also in cooling. So it would considerably reducing the amount of work done there.
Okay, so now talk about the desiccant itself. Now, do you have one solution for all, or do you tailor it based on the requirement, or what is the deal with that?
Yeah, so we have a liquid salt library, and we can customize it to the location that the client is looking for deployment, and also the the capacity itself. So these are the two aspects that affect the liquid salt that we formulate for that particular application.
Okay, so now talk about the size range. What sort of kilowatt or megawatt that you are looking for?
So first we're looking to scale up to 1 megawatt units. So that's our near-term goal. But after that, we also want to keep matching to what data centers scale up as well.
Okay, so what about shrinking it for household? Would that be viable, or this would be too messy for that?
So definitely that is a very interesting, and there's a huge market for that kind of applications, including for defense, who are always very keen on portable devices that can make water for them. But as of now, for us, it doesn't work out the economics of building that and the OPEX of running such a small unit. So it best starts to make sense at 2,000 liters per day and above that.
2,000 liters per day. Talk about in electricity. How much electricity this sort of devices will consume?
So that would be, we run 2,000 LPD units, so that's about 40 kilowatt.
40 kilowatt. So it makes sense from medium to large scale. You have not miniaturized it, but again, science will work, right? Science will still work at small scale. It's just that the economics has not been tailor-made. So, and right now your main target is to take care of big heavy loads.
Yes, correct.
Okay, so talk about what you are looking forward to, as what you are expecting your company to do in next few years. What is the short term aim?
Sure. In the next, let's say 1 to 4 years, what we're looking at is basically industry deployments, and we're talking about data centers. We're talking about anywhere there is low grade waste heat. So any sort of industrial process with low grade waste heat, chemical industries, pharma industries, and the real benefit that you see is especially if you have distilled water applications as well, because with, let's say, if you put in a 1 megawatt unit, you're going to have somewhere between 20,000 to 25,000 liters of distilled water that you're going to get apart from the cooling benefits. Okay, so that's a byproduct. So in a lot of industries where you're having distilled water, and let's say you need 20,000 liters of distilled water every day, you're going to be wasting another 20,000 liters when you do your processing for it. So that's a lot of water savings, and also saving you cost and hassle of that.
Okay, talk about how somebody can reach you.
So we are, you can reach us on our website, which is www.uravulabs.com, spelled as URAVULABS. And you can download our white paper from there. It includes technical details as well as application details of our tech. And you can reach out to us if you're interested in deployments. We can do a site analysis and feasibility analysis for your location as well as your industrial settings. And
what sort of cost they should be looking at?
That would
for
depend.
Whatever you have already sold, give that as a rough context.
So that would depend. It can be somewhere around 40 to 80 lakhs. It just depends on what is your exact
No, I'm just
size,
saying
yeah.
like they should expect this much.
Yeah,
Like
yeah.
so, let's just say under a CR, you should be able to deploy a basic at least testing and
Yes,
something, and
yeah.
then they can scale up.
Scale up, yes, yes.
And you are trying to make a modular system, right, for
Yeah.
your customer. Like this
Yeah.
is a shipping container, buy it,
Yeah.
test it, and deploy it.
Yeah.
Okay.
And also, it's like you can have any varieties of like it. So if you want to have inbuilt redundancy, let's say you wanted 30,000 liters per day. We are in process of designing and building a 30,000 liter per day single unit. But you could also do 15 of the 2,000 LPD. So that gives you a lot more backup in case we can do an N+1, N+2 kind of situation.
Okay, so this was a very interesting talk with a cooling tower that gives you water rather than consuming it, it gives you water. So this was a very unique proposition, and it's all designed in India and made in India, right?
Yes, sure.
Completely made in India. So this was a very interesting talk, and I hope to see that because India really can't afford to burn water for cooling. So this is a very good technology. I hope you all the best, and you hope you succeed a lot. So I do not want to pay for water, so free water for me.
Yeah.
So that's what we are expecting. Anyway, nice meeting you, and I hope to succeed and all of that. So bye.
Thank you.